Hello everyone, welcome to our next lesson. In 10.4, we are going to be looking at inscribed angles and polygons inside of circles. And we're going to start off with some vocab. Now, an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. Here's an example of an inscribed angle, this angle ABC. So it's different from central angle because a central angle has a vertex that's the center of the circle. And the arc that lies between those rays is called an intercepted arc. So that's this blue right here. If the endpoints of a chord lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. So here, this arc AC subtends the angle B, and the chord AC subtends the angle B. So this is just some vocab. We have a few theorems that we're going to use in 10.4. The first one is the measure of an inscribed angle theorem. So this theorem tells you that the measure of the inscribed angle is 1/2 the measure of the intercepted arc. So in this diagram right here, angle ADB is the inscribed angle and AB is the intercepted arc. And if, for example, the measurement of arc AB is 80, and the inscribed angle is going to be half that measure, so have a measurement of 40 degrees. We're going to use this theorem to solve some problems. So for the first part of example 1, we were given this diagram right here, and we're going to be asked to find the measurement of angle T and the measurement of arc QR. We'll start off with angle T. So if we're looking at angle T, we can see that it is a inscribed angle because the vertex of this angle is on the circle. The intercepted arc is arc RS, and we know that arc RS has a measurement of 48. Recall that the inscribed angle is going to have half of the measurement of the intercepted arc. The measurement of angle T is going to be half of 48. This will give you a measurement of 24. Next, we're asked to find the measurement of arc QR. Arc QR is over here, and we don't really have a lot of information about it. Notice that right here, RT is a diameter. So if RT is a diameter, that means that this right here, TQR, that arc is a semicircle. So we know that the whole thing's going to add up to 180. We also know that there's an inscribed angle here, angle R, which has a measurement of 50 degrees. So in order to find the measurement of the intercepted arc, it's going to be double this measurement. That'll give you a measurement of 100 for QT. Now, because this is a semicircle, it should add up to 180. So that means that QR is going to have a measurement of 80. Let's do this one more time. Next, we have another circle, and we're asked to find the measurement of arc DG. Arc DG is right here, and its inscribed angle has a measurement of 40 degrees. The arc is going to have double the measure. The measurement of arc of DG is going to be 80 degrees. For net 4, we're asked to find the measurement of G, and if we're taking a look at the diagram, angle G is over here. It's an inscribed angle. Its intercepted arc has a measurement of 58 degrees. So we need to take half of that measurement to get the measurement of angle G. And half of 58 degrees is 29 degrees. Let's try the next one. And let's move on to example 2. In example 2, we're asked to find the measurement of arc RS and the measurement of angle STR. And we are going to say what we notice about the angles STR and angle RUS. So let's look at what we're given. Arc SR is right here, and it is the arc that's intercepted by the angle U. Angle U has a measurement of 31 degrees. So in order to find the measurement of the arc, we want to double it. So the measurement of arc RS is going to be 62 degrees. Now we're also asked to find the measurement of angle STR. Angle STR is right here, and it is an inscribed angle whose intercepted arc is 62 degrees. So we want to take half of the measurement of this arc to give us the measurement of angle STR. Half of 62 degrees is 31. Now we're asked to say what we notice about angle STR and RUS, and we see that they have the same measurement. And this occurs because they have the same intercepted arc. Notice that the endpoints of the angle are at S and R. This implies the next theorem, actually. Inscribed angles of a circle theorem tells you that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Over here in our diagram, angle ADB and angle ACB intercept the same arc AB. And because they intercept the same arc, the two angles are going to be congruent, angle D and angle C. We're going to use this theorem for example 3. We're asked to find the indicated measure for each of these circles. So I made a little typo here. This should say the measurement of angle F. And in this diagram, we know that the measurement of angle E is 75 degrees. The arc that is intercepted is arc GH. And we're asked to find the measurement of angle F. And notice that F, the endpoints of this angle, are also at G and H. So therefore, these two angles are going to be congruent. So the measurement of angle F is going to be 75 degrees. Let's do one more together. For B, we're asked to find the measurement of angle X. We know that the measurement of angle Y is 72 degrees, and because they intercept the same arc, angle X is also going to have a measurement of 72 degrees. Let's move on to our next concept. A polygon is called an inscribed polygon when all the vertices lie on a circle. So here we have an inscribed pentagon. All of the vertices of this pentagon are on the circle. And the circle that contains all the vertices is called the circumscribed circle. We have two theorems involving inscribed polygons. And the first one is the inscribed right triangle theorem, and it tells us that if you have a right triangle inscribed in a circle, and the hypotenuse is going to be the diameter of the circle. The reverse is also true. If one side of a triangle is a diameter, then the triangle is going to be a right triangle, and the angle that's opposite the diameter will be a right angle. So here, since AC is a diameter, angle B is going to be a right angle. Next, we have the inscribed quadrilateral theorem, and that just tells you that a quadrilateral that is inscribed in a circle must have opposite angles that are supplementary. So over here, angle D and angle F have to add up to 180, and angle E and G also have to add up to 180. We're going to use these two theorems for our next example. So for A, we're given a triangle inside of a circle. You can see that AB is a diameter of the circle. Therefore, that the angle that is opposite of the diameter is going to be a right angle. This angle C should be 90 degrees. So let's set up an equation to figure out what x is equal to. Divide by 2 on both sides, and you get that x is equal to 45 degrees. Now let's move on to B. For B, we are given a quadrilateral that is inscribed inside a circle, and we know that in order for this to occur, the opposite angles must be supplementary. So I'm going to set up an equation to find why. Angle E and angle G have to add up to 180. Subtract 120 on both sides, and you will get y is equal to 60 degrees. And we're going to do the same thing with angle D and F. We're going to add them together, set it equal to 180, and then solve for Z. Subtract 80 on both sides, and you get Z is equal to 100 degrees. That's it for our lesson for J. Let me know if you have any questions. I hope you have a wonderful day, and take care.